And go. Today, we're going to talk about logarithms. And logarithms for the next kind of 3 lessons or so. People do find logarithms confusing. If you ask Mr. Snavely something about logarithms, he would say, I would need to relearn it, okay? Ms. Kiesler, if you were to talk to her about logarithms, she'd say, I need to go back and relearn it. A lot of people forget them because they don't get used a lot. They do definitely get used in calculus, but I'm going to do my best to explain what they mean. But without a doubt, people can kind of get a little bit lost during this time. Not going to lie, but we will do our best, okay? So, a logarithm. A logarithm is simply another way of expressing an exponential function. So, for example, log base A of x is equal to y. Okay, log base A of x is equal to y. That's how we read that. What it really means is a base of A to the y power is equal to x. Okay, base A to the y power is equal to x. That's what it means. So, if you see log base 2 of 32 is equal to 5. And by the way, it's not log to the second. It's not log times 2. It's log base 2 of 32 is equal to 5. That means that 2, base 2, to the 5th power is equal to 32. Now, this expression, you know, it works well with your brain. It's kind of like addition and multiplication work well with your brain. Subtraction, division don't, right? Same way exponents work well with your brain. Logarithms don't. Okay, that's not the way that we're wired, but they still are very important. This one would be 6 to the 2nd power is equal to 36. How would you write the next one?
12 to 0 equals 1.
12 to the 0 power is equal to 1 because anything to the 0 power is equal to 1. And notice that these have bases 2, 6, and 12. Well, there's also what we call assumed bases. And the assumed base for a logarithm, if you don't see one written, is 10. Take out your calculator.
We're going to need a calc.
Every day.
Oh my god.
Make sure it's charged every day.
Guess what the MT has?
No. Not a calc, I bet.
Oh, it's a calc already.
Wait, how do I get out of here?
Second quit. Second quit. And if you look, you have 2 logarithms on your calculator. One is log and one is natural log. Some people say in. This is not an I, it is an L. Natural logarithm. Why does the L come first? Because it was first a French word. It was logarithm naturel. They put the adjective after the noun instead of in front of it. Just that's the way the French language is. So natural logarithm and logarithm. The logarithm of a log is base 10. Okay? So I'm going to type in log, and I'm going to type in 100.
100.
What that means is a base of 10 to what power is equal to 100? Who can tell me 10 to what power is 100?
10. 2.
Dos, which is Spanish for 2.
It's okay, Ledger.
Thanks for laughing, I appreciate it.
10 times 10 is 100. You are absolutely correct. But we would say 10 squared is 100. What if I have the log of 1,000? 3. Because 10 to the 3rd is 1,000. We'll do a tricky one for you. What about the log of 0.1? The log of 1/10?
Is it?
-1. Because 1 over 10 is a 10th. See that? Now we're really going to try to trick you here. What about the log of 200? Don't press enter. Okay, don't press enter. The log of 200. That means 10 to what power is 200? Don't type anything. I want you to talk to your friend and make a guess. What do you think it is? 10 to what power is 200? Go, talk.
No, I'm not sure. I think it's half. It's gotta be, well, no, it's in between, it's closer to, way closer to 2 than it is to 1,000.
I think Ben's yeah.
Bro, look.
Okay, Big Ben. Okay, speaketh forth, Ben. What are you saying? It's going to be between what?
1 and 1,000, but
Okay.
Whoa.
Oh,
Yeah,
two
there you
and
go.
three. Two and
It's gonna be between 2 and 3 because the log of 100 is 2 and the log of 1,000 is 3. Good. So
It's gonna be closer to 2.
it's gonna be closer to 2, you think? So you're making a guess of
2.2.
2.2.
Whoa.
2 and 3.
No.
Oh, he's pretty close.
Oh.
Now, can everybody agree that you would not have come up with 2.30 on your own?
No.
So the way that your calculator actually does this, it involves a lot of calculus. It's very impressive. But we could come up with some of these on our own, but using that totally different story. Okay, now press the natural log. The natural log has a base of e. The base is e. E is a number 2.7. We talked about it yesterday. So, and then press second divide sign. So second divide, and that brings up your e. So this means e to what power is e?
1.
1.
Ooh. How you do it right there.
Natural log of
I took math in college.
1. That means e to what power is 1?
0.
0. Natural log of e to the 5th. E to what power is e to the 5th?
5.
5. Okay? Your calculator has log base 10 and log base e called natural log. That's where you get the e, that's where you get log, that's where you get natural log. Everybody see those?
Mm-hmm.
Okay, let's head back to your notes.
Sweet.
Letter D, log base 3 of 243 is equal to 5. How would I write that as an exponential?
Equals 243.
Good. So when you say you don't know what a logarithm is, there it is. It's another way of expressing an exponential. You still don't know why we're trying to use them. We'll teach that more to you over the course of the next couple days. Notice this one says ln, natural log. It does not say in. This is another way of stating log base e of e is equal to 1. That's what this is saying. So I write e to what power?
1.
1 is equal to
1. E.
e. What's the base of natural log?
E.
E to the
0.
0 is equal to 1. The exponent is always on the end. The exponent is always on the end. We should be able to rewrite it the other way as well. Express these in logarithmic form. So this is log base 2 of 16 is equal to 4. The exponent always goes on the end. Log base,
10.
I don't have to write the 10 because that's what's assumed for logarithm. So log of 100,000 is equal to 5. If you do write base 10, I'm not going to mark that wrong.
Whoa.
Next one, log base 8 of 164 is equal to negative 2. Do the next 3 on your own. What part of Mexico are you going? My wife and I honeymooned at Playa del Carmen. We liked it. It was good.
I've been there.
Have you? I wonder if we saw you.
No, probably
Did
not.
you get any sand?
What year did you?
Did you get any
honeymoon?
sand for us?
Married my wife in 2002.
Oh, so I probably wasn't
I
there.
doubt you were there.
I
don't know. I feel like I saw you there.
I was there in 2013,
See, that's close enough.
and I don't remember the other proof. No, I don't have. I probably could find some proof.
Did you bring sand?
I took a coconut,
All right, check it out.
and some of them got taken, but some of them we got through.
Log base 7 of 1 is equal to 0. Again, the exponent always goes on the end. Log, I don't have to write the base of 10 of 1/10 is negative 1. Again, the exponent is always on the end. And the last one, I do not want you to write this. Do not write log base e. Never write that, okay? I don't ever want to see that. you could do it in your work, and then I had one student, she was like, this is confusing to me. I said, well, go ahead, write log base e of e is equal to 1. But then once you see that, write it as natural log, okay?
I have
Yeah.
So can you explain the last one again?
Yeah. So if I have, I'll write it out like this. This one you had log base 10, so this one is log base e. Of e is equal to 1. Exponent goes on the end. This e is here, this e is here. When you see log base e, just write natural log.
Okay.
Okay.
That makes sense.
Here's one way in which logarithms are used, and we'll move to the back side. When I was younger than you guys, I was watching a baseball game. I was watching the San Francisco Giants play against the Oakland A's. Okay? And American League versus National League in the World Series. All right? And as I flip on the TV and I'm starting to watch, all of a sudden everything starts to shake. And actually, people were loud, and all of a sudden they were absolutely silent. They were having an earthquake over in the San Francisco area. And when you measure earthquakes, they measure on the Richter scale, right? So they were having an earthquake around like 8.0. And people were like, well, that's, why is it that, people were kind of confused. They're like, why is that so different than like say a 6.4? Like there had been a 6.4 a while ago, then all of a sudden it was an 8.0. And the 8.0 was super destructive, whereas the 6.4 wasn't as much. Well, this is a logarithmic scale. So 8.0 would be like a 1 with 8 zeros behind it. You get what I'm saying? So that's 9 zeros behind it. So whereas if you had a number like this, okay, do you see that that number is 10 times greater than that number?
Uh-huh.
So the 8.0 was more than 10 times greater than the 6.4. See what I'm saying? So when they measure these, they measure them on the Richter scale. So it really does impact. Useful in science all the time. Okay, now, this is a section I think is most confusing for people who evaluate the following expressions. Log base 4 of 64. That means 4 to what power is 64?
4.
Close. 4 times 4 is 16. Times 4 more is 64, so third power. Well, thank you for your response, Pete. This one, 3 to what power is 1/9?
-2.
How did you do that?
Take 3 to 2 is
3 squared is
9.
9.
Negative.
So since it's in the denominator, it's a negative. You're absolutely right, so x is -2. Next one, log base 8 of 8. 8 to what power is 8? 1. Yep. And so here's the last kind of challenging part I have to teach you guys to try to think through. And then we'll kind of move on with the next pieces in order to make sense of it. So I can do this. Here we go. All right, if you have the equation x plus 2 is 25, we solve that by subtracting 2. Everybody agreed? Okay, no big deal, right? Because those are what we refer to as inverse operations. Addition and subtraction undo each other, agreed? And this is common sense to you, right? If I had 2x is equal to 25, well, then you say, well, how do I get rid of that 2? I divide both sides by 2. And I get x is equal to 25 over 2. Multiplying and dividing are inverse operations of each other. Agreed? So what if we had x squared is equal to 25? Well, now we want to get rid of the 2 there. What do? Now, you've come to accept that as true, but would you agree that if I showed a 4th grader that I was doing this and that somehow made those go away, would you agree that they would be very confused by that? You've come to accept that over time, as that's how you undo that. Well, what about this?
Probably the natural log or something like that.
Do you see how you can't divide by 2? You can't subtract 2. How do we make a base of 2 go away? And if you look at these, we have to do the inverse operation. Adding and subtracting are inverse, multiplying and dividing are inverse, Square and square root are inverse. So what's the inverse of a base of 2? It would be the log base of 2 of both sides. And so what happens is log base 2 and base 2, they're inverse. These cancel each other out. They just make each other go away and leave you with x. That's what happens. And so if you flip over to the previous notes right at the top here, two very important qualities that we need to list about logarithms is that they are inverse operations of exponentials. They undo one another. And they leave you with just x in that situation. And for the next part, a to the log base a of x, they undo one another and leave you with just x. Kind of looks like voodoo math, but it totally is legit. So as I try to make this work for you guys as I teach it, okay, watch how I rewrite this. You don't have to rewrite it, but just kind of follow along. This is log base 4, and you said that 64 is 4 to the third power. So watch what happens. As I rewrite it like that, those cancel and give me 3. Look at this one. I have log base 3 of 3 to the negative 2. Those cancel, give you negative 2. This is log base 8 of 8 to the first power. They cancel, give you 1. So log base 5 of 5 to the x plus y, x plus y. Three to the log base 3 of 7, those cancel, leaving you with this, just 7. Natural log, 1 over e squared is the same as e to the negative 2. What is the base of a natural log? E. So those undo one another and leave you just negative 2. On today's assignment, I would expect that out of the 40 people taking this class, that 38 would have questions on at least 2 or more problems, and they would probably come up in these 3 right here. These 3, as they're mimicked in your homework, are sometimes a little bit challenging. Log base 4 of 8, notice that the bases are not the same. So what do? We try to write them so that they have the same base. This means 4 to what power is equal to 8? Well, 4 and 8 can both be rewritten so that they have the same base. What number multiplies to 4 and to 8? 2. Namely, that 4 is the same thing as 2 squared, or 2 to the 2x, is equal to, 8 can be rewritten as 2 to the
3x.
third. No x over there, just 3. So if the bases are now the same, then the exponents need to be the same. So I can disregard the bases and say 2x is 3, divide by 2, and x is 3 halves. 3 halves is the answer there. By the way, I pulled that problem straight from an ACT example. So, I mean, those are things that they would expect that you would know. The next one, what is my base? 10. 10 to what power is equal to this number? This is the square root of 0.00001. Can I write 0.00001 as a base of 10? 10 to what power gives you 0.00001? Negative 5? Good. And then that's all being taken to the 1/2 because I'm square rooting it. Well, the bases are now the same, right? If you have a power to a power, what do? Multiply. So I get x is equal to negative 5 halves. Why don't you try letter I on your own? Don't be worried. It is challenging, but just try. See what you come up with. You make some progress.
I got text. That's right.
Did everybody start by writing 2 to the x is 4 to the 1/3?
Nope.
Cubed root means 1/3 power, right? And instead of writing 4, I could write 2 to the second. So 2 to the 2/3. So now 2 to the x is equal to 2 to the 2/3, and x is 2/3.
Got the answer.
How did you do it, Keith?
So I started off by saying 2x is equal to 4, and then.
Yeah, you wrote it exactly how he did right there.
No, I didn't have that. And then I took 2 to the squared, put it inside parentheses, put an 1/3 x.
Got it. So 2 to the x is equal to 2 squared to the 1/3 power. And then you multiply to get 2/3 there. Yep. Good. Okay, so when you get to those parts of the assignment, a little bit more challenging. We're going to finish off with A, B, C, D, E, and F. We're going to leave the other parts till tomorrow. But this usually goes well for people. It says find x, log base 2 of x is equal to 3. You want to solve for x. Well, try rewriting it as an exponential. This means 2 to the 3rd power is equal to x. So what would x be? 8. Try B and C on your own. Try B and C on your own. You're good with that? Okay, this next one, x to the 1/2 is 49. We know what x is? First hour said 7.
No, it's
It means what number are you taking the square? It doesn't mean the square root of 49. It means what number do you take the square root of to get 49? So how would we solve that? This means the square root of x is equal to 49. What would you do to both sides? Square it. Yep, you get x is 2,401. Log base 2 of 0 is equal to x. That means 2 to what power is equal to 0? What's 2 to the 0?
1.
1. What's 2 to the 1?
2.
2 to the 2?
4.
We're going the wrong way, aren't we? So try the other way. So 2 to the 0 is 1. How about 2 to the negative 1?
2. Oh.
A half. 2 to the negative 2? A fourth. 2 to the negative 3?
an 8?
An eighth? Are we going to get to 0?
I don't think so. Does the factor just keep getting smaller?
Exactly. You cannot take any number to a power and come up with 0. And so you can never take the log of 0. In fact, the number that has to be there, log base anything like 2, it must be a positive number. There is no solution here. Okay. And finally, 10 to what power? 10 to the negative 3 power is equal to x. So x is 1 over 1,000. Food for thought for some of you. A couple questions came up. I thought I'd let the class know. Somebody asked a great question earlier to me, said, what grade do we need in order to get college credit for this class? Anybody know?
C.
You need 60%. And that would give you credit for the high school, and it would give you credit at Riverland, but it would most likely not transfer then. So if you want this to transfer to another college, a 70% is a grade that would transfer and then also allow you to continue on to second semester, which is college trigonometry, okay? If you're not interested in taking college trigonometry, we do have an easier track called Trig and Stats you could take, but you need that 70% to really move in that direction. So if you do want to retake a test or spend some time with me again by December 12th, I need to see you. The last thing I want to say is, especially for your juniors, I mentioned this before, but really in terms of math, we really offer this year-long course called Pre-Calc, okay? We offer the Math for College with the Trig and Stats, and some people do that route as well. Keaton said he came from that route. It was a good year to kind of get caught up on some stuff, but you're glad you're taking this one right now, right? And then we have, obviously, Calculus, which is a great course. That's 5 credits. But there's not much more than that. And I've learned something being a teacher here and a parent in Owatonna. And what I've learned is that instead of 3 math classes or 4 math classes, my son will take 7 math classes at Owatonna because they have a block schedule. So who's getting ahead when it comes time to college?
Owatonna people.
They have more opportunities. They have a block schedule just the way it is. So right now, I'm petitioning. I'm trying to offer 2 new courses next year. 2 new courses. Number 1, this is not what would fit for most of you guys, but I'll throw it out there. CIS Technical Math. So, for example,
Evan's there.
Evan is right in this spot. Okay, so Evan is going to be a linesman, great trade. And so we are going to try to get a CIS Technical Math class. It will be first semester, and it would give him the credits that he needs for that trade he's looking to.
You would need no math.
When he goes to college, he wouldn't take a math class then. Nope. Second semester, I would like to offer CIS Statistics.
Not this one.
And CIS Statistics is probably one of the most commonly taken classes for people in college. Not as much calc, but this is really where my heart is at. I love teaching calc. And again, I'm not trying to do these because that's, like, I don't get paid extra for doing it. Riverland does. Every time I get kids sign up for CIS courses, they get money. I get none of it. I don't get a $100 check, bonus, anything like that. I'm just doing it because I think that I want more people taking math here, and I want you guys to have exposure to more math that you could possibly see in college. And I think it's just the right thing to do for you guys. So I'll be surveying all y'all and see what some of your thoughts are. But these are the things that we're trying to do next year. So, okay. Take away your homework.
Okay. Are you excited or something?
I am excited. Why?
As I look at Kenzie's homework right here, she's going to be focused on section 1, 2, 3, and 4. Section 5 and 6 have to do with graphing logarithmic functions. We're going to save that for tomorrow. Okay. So please focus on sections 1, 2, 3, and 4 at this time. Okay. Give you guys some time. Go ahead.